My name is Ian Sharp. I'm Principal Technologist at ATIS and a long-time contributor to 3GPP. We'd like to welcome you to this event, and I'm going to be your moderator today. The event today is an ATIS 3GPP webinar on 5G standards development in Release 15 and beyond. As a reminder, this is being recorded and we will make the recording available. We will also email the slides to all participants in the webinar. We have three very distinguished speakers today. Next slide, please. We have Dr. Farouk Khatibi from Qualcomm talking about the services picture. We have Stephen Hayes from Ericsson talking about the system architecture and core network. And lastly, we have Dr. Imad Farag of Nokia talking about the RAN. I think it promises to be a very interesting presentation, and we've really got some very good material from these presenters. To manage the webinar, we will have all the speakers present, and then we will do a Q&A at the end of the event. You can raise questions on the chat, and I will try and ask as many as possible in the time as available. I don't want to take too much time from these illustrious speakers, but I'm just going to give you a couple of slides to set the scene. So next slide, please. Each generation of mobile technology presents new challenges and opportunities. In the 5G era, 3GPP has maintained its role as the global focus for mobile network specifications. And as we will see, is successfully keeping step with rapidly evolving technology and market needs. Delivering 5G specifications has required a truly global collaboration. A single global market for 5G creates both economic advantages for companies, as well as offering end users the best available technology and the convenience of global mobile roaming. At the same time, we must recognize the importance of developing standards that address regional needs. 3GPP is a global collaboration of regional standards organizations. As the North American partner in 3GPP, ATIS works to enable our members to incorporate regional requirements and technology innovation into the global specifications. Next slide, please. The structure of 3GPP, which you can see on the screen now, has been pretty stable for a number of years. The technical work is based on three specification groups which deal with RAN, system aspects, services and core networks. One thing I'd like to highlight on this chart is the increasing importance of the SA6 working group. This group was originally created as a focus for working on mission critical specifications in 3GPP. It's now expanding its role to deal with the general aspects of how to support the needs of vertical industries. This is an important topic which we'll hear more about during the presentation today. Next slide, please. The main subjects for today's webinar are 3GPP Release 15 and Release 16, with some views towards Release 17 and beyond. The technical completion of Release 15 earlier this year concluded a huge effort to move 5G standards from concept to reality. We're now in the midst of the technical work on Release 16, which expands on the Release 15 capabilities. Release 17 planning is going to be an important activity in 3GPP through to the end of the year. We have seen a huge range of proposals submitted, and upfront prioritization is going to be essential to keep the work manageable. So major milestones coming up, I think, are going to be the completion of Release 16 in the early part of next year, and then also the requirements freeze and timeline fix for Release 17, with anticipation of completion sometime in the middle of 2021. Next slide, please. So just sort of few concluding thoughts on the current themes in 3GPP. As I mentioned, I think the approval of the 5G late drop in Release 15 is a major milestone, making 5G a real and solid technology. We see 5G as a flexible and strategic platform for further development. We're really only at the beginning of the potential of this platform. this huge potential brings its own challenges in terms of managing the workload and prioritization in 3GPP. In all this, LTE is still evolving and not forgotten, and we know, of course, this remains important in the marketplace and something we will continue to consider during standards activities. And lastly, I think 5G is an important enabler for a new level of collaboration of vertical industries, and that's changing the type of work that 3GPP is undertaking and the way that we approach it. So with those notes, I'd like to hand you over to Farouk Katibi from Qualcomm, who's going to talk through the services piece. So over to you, Farouk.
Thank you very much, Ian. Hello, everyone. Can go ahead to the next slide, please. So what I'm planning to do today is give you a little bit of perspective on how services and requirements in 3GPP have evolved and what's the source of all those services and requirements. So take you through a story from what happened in release 15, 16, and all the way to 17. So the first slide that we are seeing right now talks about what was the initial discussion on 5G in release 15, and it started with this TS 22261 in SA1. And the main source of those requirements came about from 4 different areas. One of them, and I will go more detailed into each one of these sources. The first one is ITU IMT 2020, which is what the name for 5G is in ITU. They call it IMT 2020. Then there were some existing 4G features that were kind of moved to be supported in 5G. Then there were some new features in 5G that were brought in by telco industry, and finally some new features that were in support of vertical industry. And that last bullet is kind of important, and I will do a little bit more emphasis on the last one. In the way of background, when I say verticals, really in the way of 3GPP, we are talking about any industry that meets the requirement, the communication needs of 3GPP technologies. And the figure that I'm showing on the right-hand side, I purposely had some overlap between those circles because there are overlap requirements coming from all the 4 different areas, and that's natural and that's actually welcome. Next slide, please. So starting from IMT 2020, which is what, as I mentioned, is what ITU calls 5G. There was a lot of discussion for the last few years, and there are a lot of documents about it, and I'm actually chairing one of the groups that evaluating IMT 2020. If you look at this triangle, there are 3 vertices to it, and the top is enhanced mobile broadband, EMBB we call it. Then we have massive machine type communication, and we have ultra reliable and low latency communication. So at the beginning, that was the structure that came about, is that potentially there are 3 main areas of, if you will, communication that needs to be supported. But within that triangular, you can see there are a lot of elements to it, from smart cities, from voice, self-driving cars, augmented reality. So where those elements are within that triangular, it really shows which area they are closer to. And this one was really done, this triangular was developed many years ago, and our understanding has actually evolved since. As a matter of fact, we actually have a 4th element on V2X that we have just added in the last SA2 meeting, and now ATIS is considering potentially proposing a 5th element to it. So the starting point was this triangular. Now we are actually going to square and maybe going to higher level, maybe go to hexagon, pentagon, and so forth. So this is where the information came from IMT 2020 ITU. Next slide, please. Then in addition, there were some key features that were originally from 4G that transferred to 5G. And I have listed a number of TSs. TS are technical specifications in a 2GPP lingo. And I don't expect you to go through this, but in a summary way, basically everything from 4G to 5G got transferred, except for a few, simple ones. For example, circuit switch fallback from to GRAN and UTRAN, that did not get transferred. Seamless handover between 5G RAN and GRAN, and 5G RAN and UTRAN, and 5G RAN core network via GRAN and or UTRAN. So there were some exceptions that did not get transferred. That kind of makes sense because in reality, some of these things are really not going to be used in 5G. So outside those, almost everything got transferred from 4G to 5G. Next slide, please. Then there were some key new 5G features that came from telco industry. And telco industry obviously been involved with this activity for a long period of time. They have a good understanding of what is the future should be. So some of the key features are, for example, network slicing, and Stephen Hayes will go through some of these in more details in the next presentation. QS enhancement, separation of user plane and control plane, that was another one that was very popular and discussed. RC inactive. Latency reduction features, one of the features of one of the KPIs of 5G is to go sub 10 millisecond delays. As a matter of fact, now we are talking about sub-millisecond delays. So one of the 5G requirements was to reduce the latencies for gaming and public safety and other requirements. SBA service-based architecture is another key element of 5G that Stephen will also discuss more. NAS capability indications. Security aspects. Security has been a very big deal in 5G, as you must have heard a lot about it in the news and so forth. So security has been a big focus of 5G. And in general, EPC and Evolved Packet Core Network enhancement to support 5G new radio, and we will use NR, 5G NR via dual connectivity has been a big focus. From the perspective of QoS, usage restriction, and selection of service gateway versus PDN gateway for optimized NR, and obviously security aspects. So these are some of the requirements that came from the telco industry to make 5G unique and really a revolution compared to 4G. Next slide, please. The part that I'm personally actually excited about, and this is, and I will do a little bit more emphasis on this activity, is some of the new features that came from the verticals. As I said, verticals are all the industries that they use 3GPP as a way of communication between them. And some of these verticals, one of the major one is industrial automation. They have very specific requirements for internet support and KPIs. From the perspective of industrial IoT, it was a huge effort, and it continues to be a huge effort. Then we have the intelligent transport use cases, use of NR 5G core network for V2X. V2X is a vehicle to anything. So originally we started V2V, which was vehicle to vehicle, but then we said, okay, now vehicles can communicate to anything, so that's what now we use the V2X. So the ITS, the intelligent transport, is another key aspect of 5G verticals. Electricity distribution, this is smart grid, has always been one of the key verticals that it's been playing a very interesting role on providing requirements. Private networks is another one that is becoming more and more interesting to discuss, and this is the concept of what we call NPN in 3GPP, non-public network, that has been a very interesting discussion in 3GPP in the last year or so. And then, right now a lot of phones obviously have the UICC, your smart chip that you put in your phone, or EUICC. There is discussion about whether there needs to be an elimination of that. So the elimination of UICC and UICC requirement is another subject that came from verticals. Alternative authentication, credential, and identities for network access. This is where we talk about, again, security, and we were talking about EAP TLS work in 3GPP. So that whole concept of authentication, credentials, UICC, and those are all about how verticals are planning to use 3GPP and what are the security implications of that. And some key actors that were involved in these discussions, from industrial automations, we had like Siemens and Bosch and many others. These are all examples. Automotives, you see Daimler and Volkswagen, and Mission Critical FirstNet was one of the huge starting point that they provided a lot of requirements. Then UK Home Office, France, and others joined. And from satellite, we had a number of active participants, and we will see that as we go to release 16 and 17, satellite becomes more interesting. So these are some of the features that came from the verticals. Next slide, please. And as I said, to me, this vertical involvement is kind of very powerful story, and this is very unique in my mind in 3GPP. There has been vertical engagement starting from FirstNet and others from very beginning, but nowadays the engagement is a lot stronger. Anywhere from public safety, railway, automotives, maritime, AV production, medical, industry, logistics, UAVs, and these are just some of the examples. And each one of them, like take UAVs. UAVs by themselves, huge discussion in 3GPP, and each one of these can go a lot more details. Unfortunately, we don't have that time to do that, but each one of these, they have very unique requirements that provide very interesting evolution and discussion in 3GPP to consider what should be done to support these verticals. Next slide, please. So the Release 15 progress, 3GPP started by looking at 4 topics. The EMBB, Evolved Mobile Broadband, that was basically we're trying to do higher data rate, higher density, deployment and coverage, scalability and mobility. So, basically have your mobile phone be better, faster, etc., etc. So that was obviously one of the key points. The other key points that we're trying to do, and think about those 3 vertices of the triangular, was massive IoT. So, IoT devices going to be everywhere. We have smart meters. We have, we're going to put the IoT on bridges, on buildings, sensors everywhere. So having all these huge number of IoT devices, how do we make sure that the system can support it? So that massive IoT, the high density, has always been an interesting discussion. Then critical communications. Obviously, this was one of the key starting points in Release 15, mission critical communication requirements, industrial automation, tactile internet. So those all were discussed under critical communication. The other interesting one is network operations. We call it NEO. Basically, what are the horizontal requirements, new business model, migration, and interworking. So you can see how the 3GPP discussion has really been getting expanded and is really trying to cover a larger area of industry as well as verticals. Next slide, please. This is another view of it. This is just a colorful view of what I just mentioned, that we are expanding in all different directions from massive MTC. MTC is another name for IoT. MTC stands for machine type communication. And I should apologize. We're going to throw a lot of acronym at you guys, and we try to expand the acronym as much as we can. But 3GPP, they love to put things in acronym ways, and we will try to explain acronym as we go along. Then we have the network operation, NEO we talked about, migration and interworking, network slicing is all part of that. and obviously critical communication. We have drones, we have mission critical data, and then we have EMBB, which is enhanced mobile broadband, which augmented reality, virtual reality fits into that. High mobility in train, planes, we're talking about 500 kilometers per hour. How do we make sure that ultra high definition and holograms are supported? So this is a pictorial view of what I just mentioned earlier, that how we are expanding the horizon of 3GPP to make sure that we cover all the different verticals as well as all the different elements. Next slide, please. So what's the status of Release 15? So this is just, we're talking about Release 15. We will then look at Release 16 and 17. The Release 15, there was a lot of work on the plate. So, I think we were trying to drink off of a fire hose. It was a fault almost like that way. So at the end, the main focus of Release 15 ended up being EMBB. Things like URLLC. URLLC is ultra reliable, low latency communication. We didn't really fully address it in Release 15. We addressed it later. The NEO features were postponed as well. Things like multicast broadcast and sidelink. Sidelink, some of you may remember what we call PROSE, proximity services, and then became ePROSE, and sidelinks basically allowing devices to communicate with each other directly. So those kind of like, we couldn't really do much about it, but then future releases handle them a little bit more. Massive IoT was addressed with narrowband IoT and eMTC. Again, it is machine type communication to attach to EPC. So some of these things we addressed it somewhat, like add in narrowband IoT, but some of these features we had to push it to the future release. And then the main focus was really on this option 3 and option 2. And you say, what is option 3? It's a great question, and Stephen has a slide on that. I just wanted to mention that the main focus was option 3 and option 2 and other deployment options. And then Stephen will explain what those options really mean. And in general, SA1 requirements get stacked up for future releases. So what doesn't get done in Release 15 goes to the future releases. Speaking of future releases, next slide, please. So now we are in Release 16. So what's in Release 16? Starting from SA1 requirements to much greater details on support of verticals. And again, to me, this is exciting how Release 16 starts saying, okay, what is it that verticals want and how can we support it? What are some of the examples are cyber physical control application in vertical domain. We use it acronym CAF. And this is again making sure that we have a correct implementation of control applications. LAN supporting 5G. You would imagine, okay, so why do we care about LAN? But industrial automation, a lot of time they use LAN, so we need to make sure that we have a good support of LAN in 5G. Another one is a 5G positioning service, and Steven has a slide on this too. This is becoming very critical. There's a lot of discussion happening as we speak on 5G positioning services. And this is another subject of very high importance and high visibility. I mentioned satellite communication access to 5G, integration of satellite and 5G. This is another important one, and we have many verticals who are interested in this activity, and that's another subject of focus in Release 16. Then 3GPP SA also made a decision to focus new work on 5G system rather than evolving the 4G. So starting from Release 16, we said, okay, you know what? We did really do that transition from 4G to 5G, but let's make sure that, we have some really new requirements in 5G from the verticals and so forth. So that was the Release 16 kind of start saying, okay, what is good and new in 5G? So that was Release 16, had a little bit more focus on that. And some work continued to be in 4G and 5G, so we didn't completely drop 4G to enable the verticals. And some of these include remote identification of UAVs, and this applies to both 4G and 5G. And improvement on V2X this is vehicle to anything communication. So we continue that discussion in both 4G and 5G. Next slide, please. So key new 5G features from verticals, massive input, because industrial automation is a big thing in Release 16. So the industrial automation, a lot of the communication, a lot of discussion came from German factory operators, German electric and electronic manufacturers, and so forth. So industrial automation was a big thing. Also, there was a lot of discussion from electrical grid, that smart grid, smart meters, and so forth. So those two really took a lot of. It is taking a lot of discussion. New KPIs, key performance indicators, new architecture for NPN, non-public networks. So those were also focus of in 5G. New requirement KPIs, accuracy band for positioning, as I mentioned, indoor and outdoor. Indoor is actually very interesting. We often talk about positioning. Everyone thinks of X and Y, but indoor, there's a Z element, what floor you are, that is important too. So that accuracy, X and Y and Z becoming important. QoS, prediction and monitoring to support high reliable system. That was another focus of 5G. So new verticals started to engage. It's a good news, bad news. I mean, now we are getting all the verticals to come and join 3GPP and being active, which is really good. But then we have all the verticals coming and say, hey, we want to make sure that our requirements are taken care of, such as maritime, audiovisual production industry, TV distribution, smart city, water management, waste management, energy service, and these are just some of the examples. We have a lot of engagement with the verticals. Next slide, please. So what's the status of Release 16 and continuing going? Cyber physical control application in vertical domains, CyberCab, doing a lot of work in RAN and SA and CT, providing new KPIs. 5G positioning, integration of satellite access in 5G, and NR. NR, again, this new radio in unlicensed band. It is really not the SA1 driven, but it's supported by most verticals, and it's a big discussion in 3GPP. Next slide, please. And now, Release 17. So we talked about Release 15, went to Release 16, now we are talking about Release 17. So the pace of 5G development is slowing in SA1. It's becoming more of evolution. So, we had a huge starting in 15 and 16. Now it's kind of, we are doing more of evolution work. Verticals are still contributing. There are audiovisual production, augmented reality, virtual reality, virtual reality, online gaming, edge services, all those are still being discussed in SA1. Then we have key features that are still to be determined, but expected to follow. What are the things like strict KPIs on audiovisual sync, high bandwidth side link. Side link is the direct communication without the need of a network. Multi-hub UEs to network relay, enhanced integrated edge. So these are some of the material that going on in Release 17 now that's starting. Next slide, please. So unfortunately, I know a lot of people are very interested in details of what's going on in Release 17 and so forth. I just provided some key points on them, and these are all linked. So when the presentation becomes available, you can click on them and get more information, but kind of going to give you a landscape of what are these activities. Enhancement of cyber physical control application vertical domain, 5G enhancement for UAV, complete gap, and also for railway, mobile, audiovisual, services production, network control, interactive services. Next slide, please. And support of multi-use SIM devices is another really interesting one that's being discussed highly. And multimedia priority services, MPS phase 2. So these are some of the stuff that are now being discussed in Release 17 for a study item. And as a matter of fact, even within ATIS, we have an activity going on that would look at what should be pushed in Release 17 and so forth. So if anyone is interested, please feel free to reach out to Ian, and we will help you guide through that. So this Release 17, we want to make sure that anything that was left in Release 15 and 16 get captured in Release 17. Some of these requirements have already made it to Stage 2. So we are not waiting for Stage 1 to be completed. Some of these requirements are already going to Stage 2. And there are some examples I provided. For example, NCS is going to 5G pros discussion and so forth. So, we are not going to wait for the waterfall to finish in Stage 1 and Stage 2. Some of them in Stage 2, we said, okay, we really need to start working on this thing as soon as possible. And finally, the last thing, I do have a link there that shows all the Release 17 SA1 discussion. If you're interested, you can certainly go with that. With that, I would like to now pass the discussion to Stephen, who will give you a little bit more details about some of this material that I discussed. Thank you.
Thank you, Farouk, and thank you for this opportunity to talk about what the capabilities of the core network will be and what's being done for Release 16. So if we can advance to the next slide, please. Within the 3GPP system, there are actually two core networks that support 5G. And Farouk alluded to these earlier when he was talking about options. And you may have heard the early drop, regular drop, and the late drop. And this refers to different configurations of core networks, access networks, or radio networks, and devices that can be supported in different configurations. Most of what I'm going to be talking about is what's in the blue box here, 5GC, which is the 5G core. This is the new core that was developed to support NR and all the new capabilities that we see coming. But it doesn't mean that EPC was orphaned, the evolved packet core that was developed for LTE. It was extended. In fact, most of the deployments that you see right now probably are using this option 3, in which most of the control signaling is actually going via the LTE network, but that data can be, or user plane information can be transferred from the new radio network at high rates. So there were extensions made to EPC to allow it to support new radio in a dual connectivity mode. But most of the work that's been done in Release 15 and Release 16 in the core network is in the development of this new 5G core. And there's various configurations this can exist in. The one that you may have heard referred to as standalone or option 2 is where it's simply a one-to-one pairing between the radio access, new radio, and the 5G core. But other options are also possible, allowing support of both LTE and NR. And in these, sometimes you'll see LTE referred to as ELTE when it's supporting signaling or new types of signaling coming from the 5G core. If we can go to the next slide, please. Okay, I'm going to focus here mainly on Release 16 and the work that's been done in addition to what was done on Release 15. But as I mentioned, EPC is still being extended. Now, I've sort of cherry-picked the items that I'll be discussing. On slide 30, you can find a list of all the different work items that are going on in the SA and CT groups. And there you can get a fuller picture of the different activities. Okay, so what made the 5G core different from the evolved packet core? If you look at the architecture diagram from the evolved packet core that you can see on the lower left, you see a lot of boxes that are connected by lines, and there was essentially a point-to-point connection. And this really didn't scale well, and it was becoming horrendously complex. So in Release 15, they moved to a new architecture that was a consumer supplier architecture where you had network functions providing services and discovery and subscription capabilities to define these functions. And you could, it was sort of a cloud native type of structure that allowed you to be more flexible. In addition, there were generic interfaces that were added, these N1, N2, N4. Things were done in sort of a generic manner as opposed to 3GPP access specific. So that was one of the things that was done, this service-based architecture, and that was a key architectural change. Another one was the addition of network slicing to allow you to allocate resources, and this applied to both the UE, the core network, and the radio network. In previous networks, you'd had this concept of control plane and user plane that was sort of an add-on split that was done. This was a key fundamental architectural principle in 5G or 5GC. So you'll see that the functions, they're called network functions, are split according to this principle. There's also the incorporation of cloud and edge computing capabilities. In addition, the ability to tailor the quality of service became more granular. So instead of the concept of bearers, it was replaced with the concept of flow-based QoS that allowed finer grain control. And you'll see that in 5GC, there's a lot more classes of quality of service, including things like delay-bounded communications, etc. Now, one of the things I'm going to be talking about is primarily the architectural change, but these are actually reflected in other groups as well, not just SA2 that does the architecture. So in all of these changes I'm talking about, there'll be security implications. There may be changes needed to the media support, O&M, APIs and protocols that are needed to support it. And so all these are being done. I don't explicitly call them out, but you can find those in slide 30 in the work items, the sort of additional functions that are required within the whole system to support these new functions are described there. So even though I don't pick them out, the security work, et cetera, that's needed to support this is all being done. So if we can go to the next slide, please. So in order to group sort of the functions that were done in Release 16 that are new, I sort of split into three categories. And the first of these categories is sort of what I call catch-up. EPC evolved for a long time, so it had a lot of functionality. Not all of that can be completed in Release 15. In addition, there were some, like, for example, V2X, where in Release 15, the new radio didn't support sidelink. So it didn't necessarily make sense to have a whole new V2X capability added in Release 15 when NR didn't support this sidelink. But in Release 16 then, it was added in. And not only was it added in, even more capabilities were added to make it more flexible and usable, especially in these vertical markets that Fruit talked about. So one of the things that was done was V2X support for 5G. One of the key things that was added was support for new radio, but it also supports LTE. We added things like Groupcast and Unicast for PC5. PC5 is the interface device to device. And so that's a terminology you'll often see. Another thing that was added within cellular communications, there's a lot of QoS mechanisms, both QoS and priority for communicating different data rates with different latencies, etc. That was extended to the V2X framework. So for both network to device and device to device to now QoS mechanisms that allow communication over a variety of, I guess, customizable schemes. And finally, as Farouk indicated, there's likely to be, or there will be a V2X network-specific slice to encapsulate a lot of those changes. Another thing that was missing from Release 16 was narrowband IoT support, sometimes referred to as CIoT, cellular IoT. This was added in Release 16. The ability to migrate between EPC support and 5GC support of cellular IoT or narrowband IoT and interoperability between those. Some additional changes were made to allow small bursts of data to be sent and more efficient power savings and improved capability for management of groups of devices. Another thing that was missing was full support of location services. In Release 15, all that was provided was the ability to meet regulatory requirements such as E911. In Release 16, full support for commercial use cases was provided. And these include the ability to support roaming, various periodic triggering functions, support of the location positioning protocol for non-3GPP access. It also includes, for example, the ability to move some of the functions like the location management function out into the RAN, so it could do local computation of positioning. So essentially the LCS function was brought up to par with EPC and even extended beyond that as part of Release 16. So let's go on to the next slide. Okay, this group of improvements is actually continuing down the road of enhancements that were architectural enhancements that were started in Release 15. As mentioned, one of the key architectural changes was this adoption of the service-based architecture. But due to time, even though it had this nice generalized framework, the communication tended to be more point-to-point. But that was changed in Release 16, and now we have both indirect communication and delegated discovery through a new box or a new function called a service communication proxy. In addition, there was the introduction of what's called network function sets, which are multiple network functions that do the same thing, or network function service sets, which are actually service sets or services within a network function that do the same thing, and the ability to select between those in a more flexible way. And finally, in Release 15, IMS was essentially unchanged, so it used old interfaces. In Release 16, there was work to adapt that to the new architecture to add IMS network functions so it will work in a more native and efficient manner. Network slicing was provided in Release 15. There were some minor changes that were are being done as part of Release 16. One is that you have slice-specific authentication authorization. This is sort of a key one, since many of the verticals that use slices won't necessarily want to use 3GPP authentication authorization. And finally, in interworking with EPC. EPC doesn't support network slicing, but some changes were made to allow the proper selection of the access management function and the session management function when you move from a 5GC to an EPC, or when you move from EPC to a 5G core. So it allows more reliable swapping or switching back and forth when using network slicing. Another item that was added was improvements to user data interworking coexistence and migration. If you look at the architecture diagram under the new architecture, one of the things you'll see that's missing is the HSS, the home subscriber function, and it's been replaced by the unified data repository. Now in Release 15, they couldn't make that break cleanly. So what was supported in Release 15 was kind of a combination HSS UDR type of box. In Release 16, they tackled that so you could have standalone support of this unified data repository. And the idea of the unified data repository is that it deals with more than just sort of static subscriber data. It includes a lot of data that's dynamic, since as we've expanded the role of 3GPP, the types of data that we need to maintain to run the network and satisfy the user services has expanded. The next one is some flexible mapping. As I mentioned, there was this architectural split between the control plane and the user plane. So the ability to have different combinations of session management functions and user plane functions was added, because in some cases, a single PLM may manage UPFs or user planes that are not within its jurisdiction, or there may be cases like enterprises where they may have their separate user planes or session management functions. So different combinations are being supported there. And finally, there was something that Farouk mentioned about the support of radio capability signaling. There's a lot of different capabilities that UAs can have, and the network needs to know those. So a mechanism was added to efficiently being able to transfer this information. There's two types of radio capabilities: those that may be specified by manufacturers, or those that may be specified by providers, and how to deal with those, and the policies for managing those was done as part of that. And finally, under the architectural improvements, a network analysis function was added. And this included the ability to expose functions and triggers so that information be collected for network analysis. In addition, it includes support of things such as slicing and ultra-reliable low latency communication. So this addition of the network function is one of the things that was, our network analysis function was one of the things that was added in Release 16. Okay, let's go to the next slide. And the final thing was this addition of vertical and non-3GPP support. And that's one of the key motivators within 3GPP. And one of the things that was added was wireless wireline convergence for 5GC. Now, this could be argued that this was a catch-up item also, since wireless wireline convergence existed for EPC. But it was actually a much more complete solution and a much more integrated solution that was developed under this work item. So, because the goal of a lot of the wireless wireline convergence providers was to have sort of seamless integration, not just on the access, but also in the operations and maintenance and the deployment and in the management of the systems. So there's very tight coupling, or there's very good integration between the BBF supported wireless wireline access systems and 3GPP 5th generation core. It's supposed both wireline and hybrid access. Hybrid access is when you have both wireline connected and you have 5G radio access network. In 3GPP, part of this was done by adding trusted access from non-3GPP through something called a trusted non-3GPP gateway function that was added, and this allowed the use of authentication that might not necessarily be mobile authentication. And finally, this all made use of the generic interfaces that were developed as part of the 5G core. So there was a lot done on this. Another part that's similar, sort of related, is access traffic steering, switching, and splitting. Basically, if you have multiple flows going both over 5G accesses and non-5G accesses toward a UE, you may want to split either how the data is routed. You may want to go one route or the other, or even split the data. So those possibilities are allowed. And finally, for URLCC support, some things were added for verticals, and those include the ability to do low latency handoffs and making the network more reliable through redundant paths. There's additional things. These are kind of key ones, but if you look at the work item, you can see some additional things that were done for ultra reliable, low latency communications. Okay, let's go to the next slide. And finally, one of the key things that was done was support for vertical and non-3GPP accesses. And one of them was non-public networks. Non-public networks are whether either all of the access network is private or it's some combination of private and public networks. So both those combinations are allowed, where there's no PLM network at all, or where there's some sort of integration between it and an additional ability to go back and forth between it. That's one of the things that's envisioned, for example, in factories and things like that. Another function is support of 5G LAN. Now, this was actually been renamed, and I think it's called 5G Virtual Network because of confusion with IEEE LAN. But basically what it is when you're using the public network, but you're having basically a private network with private services, a virtual network, and those can be where they're just allowed to communicate with other people in the virtual network, or where they have some sort of integration. So that's the support of 5G LAN or 5G virtual networks. And finally, there's this idea of time-sensitive networking. And the 5G supports this more or less where it acts as a bridge, and it can pass synchronization information between different parts of a time-sensitive network and support multiple clock domains and the necessary timing information that needs to be supported in a time-sensitive network. Okay, and let's see the next slide. And as I mentioned, these links provide pointers to the various Release 16, Release 17 work items that exist. I haven't mentioned SA1 since Farouk already described those, but within the system aspect, the SA group and the CT aspect, our CT group, these describe the different work items that are going on at this moment. Okay, with that, I'd like to close out the presentation of the core part and turn it over to Amit Farag from Nokia, who will talk about the radio standardization work. Thank you.
Thank you, Stephen, and good morning, everyone. So today I'm going to give a brief overview of the 5G RAN standards. I will start by giving a quick overview of the status of the Release 15 NR standard. Then we will cover the Release 16 NR standard in more detail, talking about some of the key features being developed in Release 16. Finally, we'll get a glimpse of Release 17, including a high-level schedule and the candidate features being considered for Release 17. So with that being said, let's move on to the next slide, please. So Release 15 NR is a new radio interface. It's designed from ground up to set the foundation to meet the IMT 2020 vision in terms of requirements and use cases. In terms of the scope of Release 15 NR, it focuses on enhanced mobile broadband EMBB, and this was mentioned earlier by Farouk. Also, it covered some basic URLLC functionality, ultra reliable low latency communication. Then Release 16 will develop more this URLLC functionality. It covered frequencies up to 52.6 gigahertz, and this includes frequencies below 6 gigahertz, which is also known as frequency range 1 or FR1, and millimeter waves up to 52.6 gigahertz, which is known as frequency range 2 or FR2. Now, being a new radio interface, NR included several enabling technologies such as scalable numerology, flexible frame structure, advanced channel coding, enhanced MIMO beamforming, and many more. The schedule of NR Release 15, and this was partly covered earlier by Ian, work started on NR and 3GPP in late 2015 with several study items. The actual Release 15 NR work item, this started in March 2017, and it had a very aggressive timeline, with the first version being available in December 2017, and this covered non-standalone operation, which is also known as option 3 as presented earlier. The standalone version or option 2 of NR was available in June 2018, and then the late drop of Release 15 NR, which covers additional deployment options, mainly options 4 and 7, as well as NR dual connectivity. This was available earlier this year. Now, with Release 15 work basically done, 3GPP is moving full speed ahead with Release 16 and with planning for Release 17. And we can move to the next slide, please. So while Release 15 NR was revolutionary, it defined a new radio interface. Release 16 is more an evolutionary development, targeting new verticals, as well as improving capacity and operation of existing features. We have here a list of the main features being developed for Release 16. In the next few slides, we will cover some of those features in more details. In terms of timeline for Release 16, work started on Release 16 in early 2018 with the study item phase. Then the work item started in early 2019, and it's expected by the end of this year that the physical layer aspects of Release 16 will be complete. Then the higher layer aspects and the ASN1 freeze are expected to be completed during the first half of 2020. So let's move on to the next slide, please. So let's start with the MIMO enhancements in Release 16. But before we do that, let's just step back and look at the Release 15 MIMO. So in Release 15, MIMO introduced beam-based operation, which is required for millimeter waves. It also introduced a scalable and very flexible CSI framework and RS design. And this sets the foundation for the MIMO framework that can be further enhanced in future releases. Release 15 also introduced the Type 2 CSI codebook, which brought at least a 30% enhancement over LTE. Now, despite all of the performance and coverage improvements that were brought by the Release 15 MIMO, yet it had some limitations, and these are being addressed by the enhancements being introduced in Release 16. So Release 16 has 5 main areas of MIMO enhancements, which are CSI enhancement, and this is to reduce overhead and increase the rank of the Type 2 CSI codebook. Also support for multi-TRP and multi-panel support, and examples of these are shown in the figures to the right. Multi-beam operation enhancement, full TX power for uplink transmission with multiple power amplifiers, and low peak to average or PAPR reference signals that are being designed and introduced in Release 16. Then let's move on to the next slide, please. Another Release 16 feature is UE power saving, where the motivation here is to improve the UE's battery life. So one thing we notice about NR is that it has lots of flexibility and it has high bandwidth and high data rates. And this leads to NR devices dissipating more power than LTE devices. So it was natural to start looking at and investigating schemes to reduce the UE power consumption, to improve the UE's battery life, and also to targeting to make NR more power efficient than LTE. So 3GPP undertook a study item to develop a power consumption model and to evaluate different power saving techniques. And some of these showed promising results and are being considered for further specification, such as having a power saving signal, which is shown in the upper right, or cross-slot scheduling, which is shown in the lower left, or adaptation of the number of MIMO layers, or UE indication to transition out of the RRC connected state. The UE can also provide power-saving assistant information and relaxation of the RRM measurements in idle and inactive modes. Then if we move on to the next slide. So another feature that's being developed in Release 16 is the cross-link interference and remote interference management. And this, as the name implies, has two parts. The first part is the cross-link interference, or CLI, and this is intended to allow flexible and adaptable resource sharing in unpaired spectrum. To achieve this, CLI introduced cross-link interference measurement and reporting. It also introduced a network coordination mechanism by exchanging uplink downlink configurations. The other part of this feature is the remote interference management, or RIM, and this deals with mitigation of interference caused by base stations that are hundreds of kilometers away, and this is caused by reflection of electromagnetic waves off of the higher layers of the atmosphere. So when the interfering signal from a base station, which is 100 or more kilometers away, arrives at the victim cell, it is delayed by a propagation delay which exceeds the guard period, and this leads to the downlink part interfering with the uplink part, which could be detrimental to the UEs transmitting in the victim cell. So to mitigate this type of remote interference, RIM reference signals are introduced, and these are used to indicate and to detect the presence of remote interference. Various schemes can then be used to mitigate the effect of the remote interference when detected. Let's move to the next slide, please. So another Release 16 NR feature is integrated access and backhaul, which support wireless backhaul and relay links in band or out of band with access links. In NR, there is large bandwidth available, especially in millimeter waves, so this can be split between the access and the backhaul links. The motivation for this feature is first to improve capacity by supporting networks with a higher density of access points, even if those access points don't have fiber connectivity. It also improves coverage, and that's because it can extend the range of the wireless network. It can also provide coverage to isolated coverage gaps, and an example of this is shown in the figure to the upper right. it can also provide indoor coverage. So we can have an IAB access point on top of the building that serves the users within this building. Another motivation is that it could support group mobility, for example, users that are on a train, even though this is not within the scope of Release 16. So this might be something that will come in a later release. If we look at the scope of IAB feature in Release 16, it includes multi-hop backhauling, topology adaptation, end-to-end QoS across access and backhaul links, and other aspects. Because of time, we won't go through all of these, but these are listed here on this slide. So if we then move on to the next slide. Ultra reliable low latency communication, URLLC. So I mentioned earlier that in Release 15, some basic URLLC functionality is being provided, and URLLC has two parts. It has a latency part and a reliability part. So if we look at the latency front, in Release 15, we support higher subcarrier spacing, which are going to have lower transmission duration. Release 15 also supports mini slots, which have fewer than 14 symbols. And it supports configured grant, which basically allows the UE to autonomously transmit without having to send a scheduling request and wait for the uplink grant. On the higher reliability front, Release 15 supports PDCP duplication and lower spectral efficiency. Now, Release 16 for URLLC intends to further enhance its performance by having latency in the range of 0.5 to 1 millisecond and higher reliability with a target error rate of 10 to the minus 6. And this will allow the support of new use cases such as factory automation and use cases for the transport industry, as well as improving the performance of the Release 15 use cases. To achieve this, Release 16 URLLC focuses on 5 main areas of improvement, and these include PDCCH enhancements, UCI enhancements, scheduling and HARC enhancements, inter-UE prioritization, and configured grant enhancements. We could move to the next slide, please. So another Release 16 feature is V2X, and this was mentioned earlier in the talk by Farouk and Stephen. So V2X basically extends its 3GPP platform to the automotive industry by providing vehicle-to-everything support, whether it's another vehicle, a pedestrian, an infrastructure unit, or the network. And there are 2 ways to send the V2X messages. They can be transferred over the UU interface, which is the normal uplink-downlink interface between the base station and the UE, or directly between UEs on the sidelink interface, which is known as the PC5. And these can be seen in the figures shown on this slide here. V2X, if we look at LTE, was actually introduced to LTE in Release 14, and then it was further enhanced in Release 15. Release 16 now introduces V2X to NR. The NR V2X is designed to support internetworking with LTE V2X. Again, we could see examples of this type of internetworking in the 2 scenarios shown in the figures on this slide. And in this way, the NR V2X complements the LTE V2X by supporting advanced use cases such as platooning, extended sensors, advanced driving, and remote driving. There are several enhancements for the Release 16 V2X, and these include sidelink enhancements. So NR does not support side link in release 15. So release 16 is introducing the side link to NR. Cross control of the LTE PC5 interface from the NR interface, and UE reports to assist with the G Node B scheduling and QoS management. Next slide, please. So another important feature that's being introduced in release 16 for NR is NR positioning, and the motivation of this feature is to meet the regulatory and commercial requirements of positioning in terms of accuracy and availability, and this is by capitalizing on NR capabilities such as operation in FR1 and FR2 with higher bandwidth and with massive antenna arrays. So in release 16, there are several radio access dependent positioning schemes or RAD dependent positioning schemes that are being introduced, such as downlink and uplink time difference of arrival, angle-based positioning techniques, whether it's for the downlink angle of departure or uplink angle of arrival, round trip time positioning techniques, and ECID-based positioning techniques. So to be able to support these positioning schemes, new reference signals are being defined, such as the PRS or positioning reference signal in the downlink, and other reference signals are being enhanced, such as the sounding reference signal or SRS in the uplink. In addition, there are new measurement reports that are to be sent to the location server that are being defined for these positioning schemes. So in addition to these RAD-dependent positioning schemes, there are also RAD-independent positioning schemes that are being extended in release 16. Next slide, please. So the last feature of release 16 NR that we will cover today is NR unlicensed or NRU. And NRU basically introduces NR to unlicensed frequency bands in the 5 gigahertz and 6 gigahertz frequency ranges. The 5 gigahertz band, of course, is being used by other incumbent technologies that, such as Wi-Fi, so there will be some sharing there that needs to be taken into consideration. The 6 gigahertz band is a new band. It's a greenfield band. So licensed spectrum still is the cornerstone of wireless mobile service, and this is in order to meet the service requirements in terms of coverage, efficiency, and reliability. But unlicensed spectrum complements licensed access by boosting capacity and by improving data connectivity. So based on this, 5 scenarios have been identified for unlicensed access, as shown here on the slide, and they support both standalone type of unlicensed access as well as licensed assisted access. So with standalone unlicensed access, NR operates in an unlicensed band with no assistance from operation in licensed band. And then the licensed assisted access, or LAA, is where the operation of NR in the unlicensed band is secondary to wireless access in a licensed band. So this is a quick overview of some of the features that are being developed in release 16 for NR. Now, if we go to the next slide, we can take a look at the future and at release 17. So release 17 planning is currently ongoing, and in the last RAM plenary, which was last month in June, there was one day that was set aside for the release 17 initial presentation. The input to the RAM plenary was then categorized into work areas which cover related topics. and each work area has its email discussion to consolidate the different views and to discuss the scope and the objective of each work area. Now, it's expected that at the end of this email discussion, and I'm going into the December meeting, that the content of the release 17 will be finalized and approved at that time, and this includes the scope and the objectives of the release 17 study items and work items. The actual release 17 work is expected to start in early 2020 and be finalized towards the middle of 2021, and this will lead to about 15 months interval between the anticipated freeze dates of release 16 and release 17. The content of the release 17 work areas is roughly divided into two categories. The first category are new items for release 17, and the second category is continuation of items from earlier releases. And the table here on this slide shows the work items that are being considered for release 17. It's expected that not all of these would actually make it into release 17, that only a subset of this will be worked on in release 17. And I think with this, I end my part of the presentation. So let me turn it back to Ian now.
Thank you very much, Emad. Can we go on to the next slide, please? So before the Q&A, I just wanted to say a couple of things. Well, first of all, I would like to very much thank our speakers. I think this is a very informative presentation and a lot of really important information there. A few people have asked on the chat. We will be making slides available to the whole participant list by email, so you will get these to refer to. Just a couple of words on North America. Within ATIS, we have many initiatives that deal directly with 5G technology or have a strong intersection with 3GPP's work. You can see 6 of those on the screen here. We see the importance of regional leadership to shape the future direction for global specifications, and you heard during the discussion about the Release 17 prioritization activities. So related to that, we have an initiative on Release 17 and beyond. We're also looking at satellite integration with mobile, and we're starting even to talk about quote 6G, though what exactly 6G means I think is a bit TBD. We're also working on how 5G will be deployed and used. This week, ATIS published a report on the use of neutral hosts for 5G, which I think is an important way to deploy 5G in dense environments. We're also incorporating 5G as part of our work on IoT and vertical industry needs, such as connected cars, smart cities, and UAVs. Lastly, we see growing interest in the security of 5G, and we're working on processes to help operators understand the complex picture around system threats and how to mitigate them. Next slide, please. As well as the strategic work in ATIS, we're working on a range of specific regional technical needs in the standard, and some of these are shown on this slide. North America has long been a leader in support of public safety requirements in mobile networks. This includes wireless emergency alerts with geo-targeting, location finding and emergency call routing, lawful intercept, and the use of mobile networks for critical communications. As 3GPP progresses to Release 17 and beyond, we will continue to support the global specification work while ensuring these regional needs are met. With that, I would now like to turn to any questions. So if you have some questions, please feel free to put them into the question box on the chat. While we're waiting, I guess, Stephen, we had a number of questions, and I know you answered them by the chat, but it might just be worth an additional comment. Do you want to maybe just reflect on what you see are the main trends in terms of which of the options are being used for 5G deployment, and what are the consequences for operators with existing LTE networks for different 5G deployment options?
Okay. I guess the two main architectural options that were done initially were option 3 and option 2. Option 3 was where basically the LTE remains as the backbone. Since you have larger coverage with your LTE network than your NR network, the LTE continues to handle the control signaling. And then the user plane signaling makes use of the NR network where it's available. This is the most common option. And then the other option was sort of this that was produced next was standalone option where it's 5G everything. It's a 5G core connected to a NR radio. And this is more or less sort of a standalone option. The options that exist, the other ones, the 4 and 7, these are ones I suspect you will see as you as sort of early adopters transition to a 5G core. They'll need a 5G core to eventually get all these new functions, because while EPC provides support for NR, it's not really supporting all the new services that are envisioned. And there's two ways of doing it. There's option 7, where you continue to use the control signaling going toward LTE, but again, that's limited by the capabilities of the control signaling that existed. Option 4. Okay, in 5GC, for option 7, that's where what you would get if you take option 3 and swap out the 4G core with a 5G core. And then the expectation is that that LTE will actually be an enhanced LTE that's now able to support all this new control signaling and new functions. And finally, option 4 is one that you would see in the future. Once you have good coverage from your NR network, then you can put the control plane on there so that basically everywhere the NR network is sufficient to provide the control coverage and the user plane coverage, and the LTE then is just a supplement. So I think those are sort of the combination, the evolution that we see, but there's a lot of work going on in GSMA and in 3GPP on how to handle these migration scenarios.
Okay, thanks, Stephen. A question, I don't know whether it's best tackled by you or Farouk. What's the story on support for voice services in 5G? Maybe offer that one to Farouk.
Actually, you know, Stephen, and maybe this is more of an architecture. Maybe would you like to take that?
Well, as was mentioned, well, there is support, but in Release 16, what was done was this enhanced IMS. So it's supported in Release 15 using the VoLTE type functions, but in Release 16, the IMS is migrated to service-based interfaces, and it's supported more flexibly. But the answer is it is supported. I'm not sure what the question is exactly, but
okay, supported using IMS is I guess the sort of short summary, correct?
Yes, because the IMS was taken over more or less intact for Release 15, so it was really, it didn't lose or gain any functionality.
Yeah, okay.
Right, and I think if I may add, as Stephen pointed out, it's important that IMS is becoming an SPA. So we are creating IMS in the form of 5G. So we take the IMS, but we incorporate into the 5G SPA architecture. So that's important.
Okay, thank you. So another question I have, are LAN services confined to unlicensed bands, or are they available in licensed spectrum as well? Anybody want to comment on that?
Did you want to answer that, or? I don't know, Imad, are you unmuted? So anyway, so
So I think LAN services will mainly be in unlicensed bands. Maybe that's more, I would think, an architecture question, but
yeah.
From a RAN perspective, it could be either way, but I think architecturally, it will be an unlicensed spectrum.
Yeah, this is Stephen. I think you need to distinguish between LAN or 5G LAN or virtual networks, which is basically providing sort of virtual network services over a public network. And being over a public network, this would likely be in licensed spectrum, and non-public networks, which in many cases will be over, would normally be over unlicensed.
Right, and if I may add to what was just said, like industrial automation obviously has a lot of interest in this LAN discussion, and that relates to, as Stephen said, to non-public network NPN. So there is no spectrum necessarily, but if there needs to be, I mean, often it's about a non-licensed band.
Yeah, no, I think that makes sense. And another subject entirely, the status of vertical positioning. Anybody would like to comment on that?
Vertical provisioning?
Positioning.
Oh, positioning. Oh, vertical positioning. I'm sorry. My mind is on vertical. Vertical. So, I actually, that's a good question. I should point out that actually the major activity on that is actually in ATIS. We have done work on this group called ELOC, ELOC, that we create an architecture to allow for not only X and Y, but also Z, using barometric pressure and other techniques. So there's quite a bit of activity going on in ATIS, and we have published a lot of standards in ATIS, and that work is ongoing in 3GPP as well. As a matter of fact, ATIS, we took a lot of CRs to 3GPP on the subject, so that work is ongoing.
Okay, yeah. I mean, I think that's certainly a key area for the evolution of location services, and as you say, something that's been another example of where North America has sort of set the agenda for the rest of the world. I guess we have one question which specifically mentions relationship between 5G and front haul, mid haul specifications at eCPRI. I mean, that's a whole subject in its own right. So I don't know whether we can summarize that in a couple of words, or whether this could be perhaps a future topic for another event. But anybody particularly want to comment on front haul, back haul, mid haul in the context of 5G standards?
So maybe I could comment in that in release 15, 3GPP looked at various split points between the central unit and the distributed unit. And what eventually got standardized in release 15 is the higher layers are, which includes the PDCP, will be more in the central unit, and the MAC and lower layers are in the distributed unit. Now, there are other split options which we can have the split, for example, within the PHY or between the PHY being the physical layer. So the split within the physical layer or between the physical layer and the MAC layer. But these have not been standardized yet, and there are other standard bodies outside of 3GPP that are looking into these things, like, for example, eCPRI, that are looking into these types of split functionality.
Okay, yes, thank you. So I think that, unfortunately, we've got a few questions we haven't been able to get around to. We will try and look at those as well, but I think we've run out of time for the presentation today. I'd like to once again thank all our three speakers. So that's Farouk Katibi from Qualcomm, Stephen Hayes from Ericsson and Emad Frag from Nokia. I think it's a very informative presentation. I hope the audience found it useful. We will be making the slides available to all registered attendees. We welcome your participation in future events of this kind, and if you have suggestions for topics, I think we'd be very interested in hearing those. So with that, I think we are done for today. We thank you again, and we look forward to having a chance to work with you again soon. Thank you very much.